All right, welcome back to our Arduino IDE class. Today we're going to go over lesson 1, which you can find in your folder S26 as in the CD attached to your kit. And if you look in the folder, you notice there's up to 28 lessons. So we have quite a ways to go, but it's like I said earlier, it's the little building blocks that actually make you realize how powerful some of the components and some of the little things you'll be learning using this kit can be. So today we're gonna go over lesson 1. If you open it up, you can ask your parents to print a PDF copy when they go to work and bring it to you. The PDF copy is right in here next to the folder labeled sample code. Solely you can ask Papa to print it when he goes to work, so he can bring you guys a printed copy so you can read from it. And Mama boys, yeah, you should print it for the boys too. Okay. All right, so this simple exercise calls for 1, 2, 3, 4, 5, 6 of the components we have in there. My Arduino is currently plugged into my computer, and it's all set up. You can see the orange LED light there blinking. And this exercise is going to need a 330 or a 220 ohm resistor. If you look in the LED, you can find a good description of it. The resistors would be with the rest of them in little things like this. Just pull out one of them, and that's all we need. And then we're going to need 2 or 3 of these jumper wires. And then we're going to need an LED light. LED stands for light emitting diode. And if you don't know what that means, it's okay. You're going to learn what it means by learning how to use it, which I think is a better way to learn. But I think Ian and Victor and Soli have probably seen this in class, in your physics class or something. The light emitting diode only allows current to flow through in one direction. So you need to pay attention to the pins. You notice one is longer than the other. The long one is the one that needs to be attached to the positive end. So if you had a battery and you were to attach the LED, make sure that the plus side of the battery attaches onto the long side. Otherwise, it will not shine, because the LED only allows current to flow through in one direction. And we're going to need a breadboard. Like I said in my introductory video, a breadboard helps you build circuits without having to manually attach wires. If you recall, we talked about these 2 outer rails that we call power rails, and it's used to distribute power to the rest of the circuit. The middle areas that you have here labeled A through J, this is where you put all of your components. If I were to attach this resistor onto the breadboard, I'll attach it in the middle areas, and then you use the outer rails to get power. And in most of what we'll be doing, we'll be getting power from our Arduino board. And eventually, if we need external power, there's a battery like this in your kit. We're not going to be using that today. Okay. So the reason we use a resistor in the circuit is because if you connect the LED directly to current, the current flowing through it is a little too high. And what will happen is it burns up the LED. Okay, it heats up and it burns it. Okay, so what we do is we connect this resistor in series with the LED so that it eats up a little bit of the current and allows just enough to flow through the LED. Now there's this image in the PDF for your lesson 1 that shows you what the rails look like underneath the breadboard. Okay, you have the 2 outer rails that are power rails, and then you have these middle rails with a center divider. So this will kind of give you an idea of why the pins are the way they are on top of the breadboard. Read through it. If you don't understand, it's okay. We'll learn as we play with it. Alright, I'm gonna go ahead and show you guys a couple of different ways, okay? Make sure you follow along with the instructions on the lesson plan, okay? So right now I'm connecting my resistor, and pay attention to what rail you connect your components to, okay? And then I'm going to put my LED onto the board. Remember, pay attention to what location you put the long pin, because the long pin is supposed to go to the positive end. I'm going to show you guys 2 ways of how to get power to that LED, and then how to program how fast it's blinking. The first way would be getting the power onto the power rails and tapping it from the power rails, just so you can see how the power rails are used, okay? Now there's a pin section that says ground on your Arduino. Remember, typically what I like to do is I use the red wire for the live wire that connects to the positive, and then I use the black wire for the neutral that connects to the negative. So I'm going to connect the black wire to the one that says ground, and then I'm going to connect it to one of the pins on the power rail. Now I'm going to connect the red wire to pin 13, and then I'm going to connect it to the positive pin on the power rail, okay? Now, how do you get power from the rail onto your LED? I'm going to use another red cable on this part of the power rail. Make sure it goes into the red line, okay? Don't mix the two up. All right, and then I'm gonna go over to where I had the positive of the LED. Remember, the long pin. Those two are connected across. Right now, my LED is connected on the A line in one of the center dividers. So I'm gonna go over there and plug in my live wire. Now, in order to complete the circuit, I'm going to plug this in to the ground, and then I'll plug this onto the line that has the resistor. And as you can see, the LED is blinking. Now let's take a quick look at the code to see how we can control the frequency of blinking of the LED. You'll find a sample code at the end of your lesson, and if you open up the Arduino IDE, here's mine. Hopefully I can make that clear enough. There you go. So basically what I did here was follow the instructions on the sample code, and I wrote it out so I don't have to videotape myself writing out the code. And I'm going to explain it line by line, okay? So the first line that says int LED equals 13. This line defines the LED. It names the LED as 13. Okay, int stands for integer. As you learn coding, you realize that we typically will have to define every single variable before we use it. Don't worry about it for now, okay? This first segment here is a setup that runs at the beginning. Okay? And if you look at the lines with the /, it's a comment that the computer does not read. Those comments are helpful for you as a coder. So you see the line here, it says put your setup here and run it once, to run once. And then that's where I put the pin mode, and then in parentheses LED and output. That's defining the output. And then the next segment, and remember, code always starts with open parentheses and close the parentheses. The next segment is something that runs over and over. That's why we call it a loop. You know, it's like a circle that goes around and round and round until you stop it. The reason we have it in a loop is we're trying to make the LED light blink. And in order to have it blink, you need it to run and then run again and run again until you maybe plug it out of current. And we'll be making use of these loops as we go on. And if you look at the comment that has the / in front of it, right here it says put your main code here to run repeatedly. Okay, that's the word there is run repeatedly. And so what this code does is it first of all turns the LED from low to high. You see it says digital right here. High means it's either 0 or 5 volts, I think, in this case. And the difference between a digital and an analog output is the digital output only has 2 states. It's and in binary codes we call it zeros and ones. Okay, which is typically it's either no current at all or 5 volts in this case. So we turn it to high. Now delay 2000 means it's going to delay it for 2 seconds. The way this program calculates time, it calculates time in milliseconds. And so if I needed it to delay for 1 second, which I'm going to right here, I'll go in there and switch it from 2000 to 1000. And when you kids write your code, I'll need you to play with that a little bit just to see the difference, okay? Switching it from 2000 to 1000 makes it delay for 1 second. And if I switch it to 10,000, that's 10 seconds. You're smart kids, you can do the math. And if I bring it down to 500, that's half a second. If I put 1, that's 1 millisecond. 1 millisecond is 1 over 1000 of a second. So if you edit the code, now look at how fast the LED is blinking. Okay, it's blinking once every 2 seconds. If I edit the code and go up here and click on upload, it sends those instructions to the circuit. And now if we go back in there, it's blinking once every second. So if I go back into the code again and change that to, let's do 200. That way it blinks super fast. 200 milliseconds will be 0.2 seconds. Okay. So we do 200. We hit upload. It sends the instructions over to the circuit. Now look at how fast it's blinking. it's going crazy. All right, so that concludes our first lesson. Make sure you try this. Make sure it works. Your homework or something to do after trying what we just went over is playing with the time. Put the time up a little bit and tone it back down to see it actually change on the circuit. And let me know if you have any questions. I would like to see short videos of what you guys have working. If you're able to set this up and have it work, use your mom or dad's phone and record a 1 to 2 minute video, send it to me on WhatsApp. Snap me any questions, and I would be sending out lesson 2 next week. All right, see you guys.